We're on lesson 24, unit 5-2 in the pre-calculus book. It's on page 285. And so we're looking at trigonometric ratios in right triangles. What we talked about before was standard form of an angle. We talked about clockwise and counterclockwise rotations. We talked about coterminal angles. We talked about reference angles, and we talked about quadrantal angles. We talked about degrees, minutes, and seconds, and going back and forth. So that's what we've covered so far. What we're fixing to do now is go back and reinvestigate sine, cosine, and tangent, which you saw in geometry, but you probably didn't see cosecant, secant, and cotangent. And so we'll introduce you to a few new ones today. And then we'll go back to our 30, 60, 90, 45, 45, 90 triangles, take a little glimpse at those, to get ready to build our trig tables, which we'll build later. All right, so first of all, a right triangle is a triangle that has 190-degree angle. Now, remember that an angle is a figure formed by two rays with a common endpoint, as we talked about in the first of the trig class. The two sides that make that right angle are called the whats of the right triangle, legs. And the side across from that right angle we call the hypotenuse, which I'll abbreviate. Now, if we look at a particular angle, let's just call this angle x degrees. If we're talking about a particular angle of x degrees, which normally in trigonometry, instead of using x, a lot of times we'll use theta or alpha or beta, some Greek symbol to represent our angle rather than x, but it's no different if we call it x, okay? So we could say theta, we could say x. Now, if we call this angle x and we want to know how these sides are related to the angle x, then we got to be thinking about angle x. Angle x is a figure formed by two rays with a common endpoint, right? Notice if we choose one of the acute angles, remember when we were dealing with reference angles, we were dealing with acute angles, so we're kind of continuing that thought. If we take one of the acute angles of the right triangle, notice that one of the sides of it is a leg and the other one's a hypotenuse. It will always be that way. One of the legs of the right triangle as related to that angle, we're going to say is the leg opposite that angle, and the other one we're going to say is the leg adjacent to that angle. Which of those two legs would you consider to be the leg adjacent to the x degrees? Well, what does adjacent mean? We usually say next to. Now, if you want the definition of adjacent angles are two angles, like this one and this one, in the same plane with a common vertex, a common side, and no common interior points. That's the fancy definition of adjacent angles. But what we get in our mind visually is next to it, right? Something beside it, next to it, adjacent. We could say that that room, this is 208, room 20, whatever that is adjacent to this room because it's the room next door, okay? So, which leg then is the leg adjacent to the x degrees? Well, it's going to be the leg that helps create the x, you see. And then we would call the other one the one opposite that. See, it's across from it. And so, in relationship to the x degrees, we would say that the leg there on the bottom is the leg adjacent, and the leg over to the left is the leg opposite of the x degrees, okay? I understand leg opposite, leg adjacent. Now, it's important to always say leg because people will just say adjacent. Do you notice that the hypotenuse is also adjacent? But it's not a leg adjacent because it's not a leg, okay? And so we're going to begin to learn our trigonometric ratios. The three main trigonometric ratios spelled out are sine, cosine, and tangent. Abbreviated, sine is S-I-N, Cosine is COS, and tangent is TAN. Now, they're ratios, a sine ratio, cosine ratio, tangent ratio. What's a ratio? Ratio is a fraction, A to B, right? Where A and B are whole numbers, and B is not zero. I mean, that's the fancy definition of a ratio. So when we say sine of x degrees equals something, we're talking about it's equal to a fraction. It's a sine ratio. Sine x is equal to some ratio. Okay? Cosine of that angle x degrees is equal to some ratio. The tangent of some angle x degrees is equal to some ratio. And we could have put theta instead of x. Now, the sine ratio is the length of the leg opposite angle x over the length of the hypotenuse. And I don't want to just put opposite. We want to put leg opposite because there's a difference in the side or leg. The cosine ratio is equal to the length of the leg adjacent to that angle over the length of the hypotenuse. And the tangent ratio is equal to the length of the leg opposite that angle over the length of the leg adjacent. And we really should be even more specific than I just wrote it. We should say the sine of x degrees is equal to the length of the leg opposite x over the hypotenuse. Cosine is the length of the leg adjacent to that angle x over the hypotenuse. And the tangent of that angle x is equal to the length of the leg opposite that angle x over the length of the leg adjacent to that angle x. Okay? Any questions there? Okay? We call these trigonometric ratios. Trigonometric ratios. Whoops. Which is the beginning foundation to our work in trigonometry. Okay? Now, this is the basic foundational functions, and then what we're going to have is the reciprocal functions. Which is more memory work. Reciprocal functions. What does reciprocal mean? Flip it over, right? Flip it over. What's the reciprocal of 3/4? 4/3. What's the reciprocal of x over y? Y over x. What's the reciprocal of leg opposite over leg adjacent? Leg adjacent over leg opposite. Okay, so we realize when we reciprocate it doesn't matter what's in there. Okay, so reciprocal functions, and so what we can say is that the reciprocal of cosecant, or the reciprocal of sine. Now, how would we talk about the reciprocal of sine? What would you write? 1 over sine, right? The reciprocal of sine is 1 over sine. I'm going to put the theta. Okay, so we're saying, what is it that is the same as the reciprocal of sine? And the thing that is the same as reciprocal of sine is cosecant. And you just have to memorize this. We're learning a brand new language in here. Okay? CSC, theta, And you'd write it out, cosecant. That's the word, cosecant. Abbreviated CSC. And then the reciprocal of cosine. And the way we show reciprocals 1 over. So the thing that we say is the reciprocal of cosine is secant. SEC. So cosecant is reciprocal of sine. Secant is reciprocal of cosine. And then when we talk about 1 over tangent, don't forget notes are mandatory. Some of you might have forgot they're mandatory. We remind you generally with the tensions, but we're going to do it free this time. In the future, we'll remind you with a detention. I hated to say that with the video going, but that's okay. So reciprocal of tangent is cotangent. Which we write out like that. So the three main trigonometric ratios are sine, cosine, tangent. Their reciprocals are cosecant, secant, and cotangent. So if cosecant is reciprocal of sine, then cosecant's what over what? The reciprocal of what sine was, right? Hypotenuse over leg opposite. See that? And we may not try to memorize what cosecant, secant, and cotangent are. We memorize what the others are, and then we say, this is the reciprocal of that, and we flip it. Eventually, with time, you'll know all of them. So we're going to focus our memory work on the originals, and then memorize what the reciprocals are by name, and then we can figure out the reciprocals from the originals. Again, with time, you just kind of get to where you know all of it. Okay? Any questions on that? So we learned the basic trigonometric ratios, sine, cosine, tangent, and we learned what the name of their reciprocals were. Now, one of the things that we need to look at, too, is a specific relationship here. So let's take a look at one other relationship. I'm going to let me just redraw this really quickly. And I'm going to call this angle X, and I'm going to call this angle Y. If I wanted the sine of angle X, let's just put some numbers in here. Y'all remember the Pythagorean triplets, 3, 4, and 5? Y'all remember that? Pythagorean triplets, 3, 4, and 5. So what would you say that the sine of X is? Sine of angle X as a ratio with those numbers? It would be the leg opposite the X, right, which is here, which is 3, over the hypotenuse 5. So the sine of angle X is 3/5. Do you understand that? What if I did the cosine of Y? Cosine is leg what? Adjacent. Cosine's leg adjacent. What's the leg adjacent to Y? 3. The leg adjacent to Y is 3. Are you seeing that the thing that is adjacent to Y is the same thing that is opposite of X? The thing adjacent to Y was the exact same thing that was opposite of X. And sine is leg opposite over hypotenuse. Cosine is leg adjacent over hypotenuse. So we had the hypotenuse both times. So what you're seeing is that the sine of X and the cosine of Y are the same. Now, what do we know about X and Y? They're complementary. The acute angles of a right triangle are complementary. So we could, from that, say that the sine of X degrees is equal to the cosine of, how could you write that as a formula? 90 minus that, right? They're complements, right? The sine of the one acute angle is equal to the cosine of the other one, and the two of them have to add up to 90. So to get one of them, you take 90 minus the other one. Now, let's look at something else. Let's say that I had tangent. The tangent of x degrees, let's just write it up here. Tangent is equal to what of x? Leg opposite 3 over leg adjacent 4. What about the cotangent of y? What's cotangent? The reciprocal of tangent, right? So if we thought about the tangent of y, let's just think tangent y for a moment. The tangent of y would be the leg opposite y4 over the leg adjacent to y3, but the reciprocal of that is 3/4. So tangent y, tangent x, is equal to cotangent 90 minus x. The sine and cosine of complements are equal. The tangent and cotangent of complements are equal. Okay? And we could do that with secant and cosecant, and it would still come out the same. And so we could also say that secant of x degrees is equal to the cosecant of 90 minus x, and we get the indication of why we said sine, cosine, tangent, cotangent, secant, cosecant. So a function and its if you will, the sine of one angle and the cosine of that, its complement are equal, okay? These are called cofunctions. Cofunctions. Cosine and sine are cofunctions. Cotangent and tangent are cofunctions. Cosecant and secant are cofunctions. The complements of cofunctions are equal. I'm going to write that down. The complements, the cofunctions of complements, let's say that. The cofunctions let me spell that right. That was goofy. Okay. So we just learned that the cofunctions, sine and cosine, of complements are equal. That's what we just discovered. Okay? So we talked about the three trigonometric ratios, sine, cosine, tangent. We talked about reciprocal functions, cosecant, secant, cotangent. And now we've talked about cofunctions and their complements. Okay? What is the reciprocal of sine? Cosecant. What is the cofunction of sine? Cosine. The cofunction of sine is cosine. The reciprocal of sine is cosecant, you see. It's a little bit confusing. Got to do a little studying because you'll get them mixed up. Okay? Any questions so far? Now, what we want to do at this point is we want to build a little mini trig table with the information that we have just to start thinking in this direction. We should recall from geometry in days gone by the rules for a 45-45-90 triangle and the rules for a 30-60-90 triangle. Whoops. Now, there's several ways this could have been presented to you. And we're going to end up with a certain way. What we want you to recognize is that in a 45, 45, 90 triangle, there's a ratio. And the ratio is that the legs have a 1-to-1 ratio. In other words, legs are equal. And the length of the hypotenuse is equal to the length of a leg times the square root of 2. Now, you may have seen that as x, and x square root of 2. Okay? And if you look in your trig book on page 287 at the top, you will see that y, and y square root 2. I'm just going to leave it 1, 1, and square root 2. Okay? If we look at a 30, 60, 90 triangle, the side across from the smaller angle is the smaller side. Let me put those back in there. Try again. "30, 60, 90 triangle. Opposite the 30 is the short leg 1. The hypotenuse is twice the short leg, and the length of the long leg is equal to the length of the short leg times the square root of 3. You remember those ratios from geometry, 1 to 2 to the square root of 3. Now, this is not what it's going to look like in the unit circle we're going to talk about later, but this is what it looked like from our memory work on right triangles. Now, I should have made the shorter leg look shorter. I didn't draw that very proportional. But let's just talk about this. Let's say, let's just talk about the angle, and we'll talk about the function, and we'll talk about the ratio. We're going to talk about 30 degrees, 45 degrees, and 60 degrees, just to show you how we're going to start building that trig table in the corner of that board over there on the wall. Okay? 30 degrees, whoops, 45 degrees, and 60 degrees. Let me go back and fix that. Didn't land where I wanted it. All right, so if we say function sine, what is the sine of 30 degrees? Well, it's the leg opposite the 30 over the hypotenuse. The sine of 30 degrees is 1/2. See, we're starting to build that table. Okay? What about the cosine of 30 degrees? Well, cosine 30 is leg adjacent to 30, square root 3, over hypotenuse 2. Leg adjacent over hypotenuse is square root 3 over 2. And see, that's going to become like multiplication tables. You're going to memorize that forever, along with everything else we're doing in trig. And then we're going to say, okay, what is the tangent of 30? Well, the tangent of 30 is the leg opposite the 31 over the leg adjacent to 30 square root 3. And so the tangent 30 is 1 over square root 3. But you can't have a radical in the denominator, so we would have to rationalize, and you would get square root 3 over 3. Square root 3 over 3. And so we began to build that trig table. Okay? And we could do the same thing for 45, and we could do the same thing for 60, and we would begin to build a chart. And you can see the rest of that chart there on page 287 at the top. And we will spend more time trying to build this chart later. Okay? Any questions on that? All right, so let's go to the worksheet, and let's do the lesson 24 portion of that. So we're on question number 11. we want to write the sine of angle A as a ratio. We want to write the cosine of angle A as a ratio. We want to write the tangent of angle A as a ratio. And then number 14, we'll get to it in a second. Now, we know, and we're going to go ahead and write the rules in, we know that sine is what over what? Leg opposite angle A over hypotenuse. And we'll just put leg opposite over hypotenuse just so we kind of remember. So what is the leg opposite angle A? Well, we don't know. How could we find out? Pythagorean theorems. We're going to say, okay, a squared plus b squared equals c squared. We're going to let this be our A, the other leg be B, and the hypotenuse is our C. So we're going to have a squared plus my B, which is 12 squared, is equal to my C, which is 13 squared. Okay? So we get a squared plus 144 is equal to 169. Subtract 144 from both sides. We get a squared is equal to 25. Take the square root of both sides, and we get a equal 5. So we use the Pythagorean theorem. Shelby, you're dismissed for the day. I'll send an email to the principal that you're not interested in pre-cal. See you tomorrow. All right. So we know that the sine of angle A then is equal to the length of the leg opposite of angle A, which is 5, over the hypotenuse, which is 13. And so sine angle A is 5/13. Any questions on number 11? Yes, sir. Yes. Yeah, because we're dealing with that picture. That's right. Yes. Uh-huh. The cosine of angle A, cosine is leg adjacent over hypotenuse. So what is the leg adjacent to angle A? The 12. The hypotenuse is still 13. So the cosine angle A is 12/13. Tangent angle A is the length of the leg opposite angle A over the length of the leg adjacent to angle A. The leg opposite angle A again was the 5, and the leg adjacent to angle A was 12. Any questions on that? Now, on number 14, what we're saying here is if sine theta is 9/11. Now, this has nothing to do with that picture over there anymore. We just changed pictures. We're just making a statement if sine, did it say theta? Theta is 9/11. Then cosecant theta is equal to what? Now, we know that cosecant is the reciprocal of sine theta, right? So using our reciprocal rules, if sine theta is 9/11, then cosecant is its reciprocal 11/9. Any questions on number 14? That's all we do. Just wanting to recognize our reciprocal rules, our reciprocal functions. Number 15. Number 15 said if secant theta is -3/4, then then we'll just say cosine theta. Then cosine theta Now, what do we know about secant? We know that secant theta is equal to the reciprocal of cosine theta, right? That's a S here. I guess I better scoot that up so you can see the S. No, I just fill it in. I'm just giving you the rules as we go just so you have them to study. Okay, if secant theta is the reciprocal of cosine, that tells us the opposite's true, right? Cosine is the reciprocal of secant. So cosine is the reciprocal of that. What's the reciprocal of negative 3/4? Negative 4/3. When you take the reciprocal, you do not change the sign. Now, people mess that up because when you deal with perpendicular lines have inverse reciprocal slopes, meaning flip it and change the sign. So don't get that confused. Reciprocal is just to flip it. Inverse reciprocal, flip it and change the sign. Inverse reciprocal has to do with perpendicular lines, slopes. Okay? Any questions on numbers 11 through 15? Okay? And then what we're doing on the rest is we're naming all of the trigonometric ratios just from that picture. Okay? So we're going to draw another picture and kind of do the same thing. So in the next picture we have 17, 8, and we don't know this one. So we're going to use the Pythagorean theorem. We're looking for b. So we're going to say a squared plus b squared equals c squared. So we get a, which is 8 squared, plus b, which we don't know square, is equal to the hypotenuse c squared. We square what we can. We get 64 plus b squared equal 289. Now we're going to start to undo. We're going to undo addition by subtraction. We're going to have b squared is equal to 225. And then we're going to get rid of the square with the square root, and we get b equal 15. So now we have all three sides, and so we'll be able to write all of those ratios. So number 16, the sine of angle R. The sine of angle R. And angle R was up here. I moved it, so you got to be careful, right? The sine of angle R is equal to the length of the leg opposite angle R, which is 15, over the length of the hypotenuse 17. Cosine angle R, the cosine is equal to the length of the leg adjacent to angle R, 8 over the hypotenuse 17. The tangent of angle R is equal to the length of the leg opposite angle R, 15, over the length of the leg adjacent 8. Cosecant, which one of those is cosecant the reciprocal of? Sine. Cosecant is the reciprocal of sine, so it's the reciprocal of 15/17, which is 17/15. Which is 17. Whoops. Ooh, that got way off. 17/15. There we go. All right. Number 20. Whoa. Number 20, we had secant. Secant angle R is equal to, well, secant is the reciprocal of cosine. So the reciprocal of 8/17 would be 17 over 8. And then the cotangent of angle R. Cotangent is reciprocal of tangent. which was 15/8, and so cotangent is 8/15. Any questions on sine, cosine, tangent, their reciprocals, and their cofunctions? All right.